In this lecture, we are going to come back to the ACF and the PACF and apply them to stock returns. So why are we doing this now in this kind of weird order? Now you might at first think these lectures are totally disorganized. Why are the ARIMA coding lectures all split up? Why did we look at the ACF and the PACF so many lectures ago, only to return to them now for stock returns? Well, there is a method to the madness. I think it's important to start with the most obvious approach first. In the case of ARIMA, the most obvious approach, if you have the choice between auto ARIMA and the old school methods, I think most of you would choose auto ARIMA. And yet, we've seen that auto ARIMA does not always give us what we might consider to be the best model. That is, when we disagree with the Akaike information criterion. So the goal of this lecture is to take a step back and consider, what would we do if auto ARIMA didn't exist? This lecture is going to walk you through a prepared Colab notebook, although a very good exercise, which I always recommend, is once you know how this is done, to try and recreate it yourself with as few references as possible. As always, you can check the lectures, how to code by yourself, and how to practice for a more in-depth discussion. If there's anything in this lecture you didn't understand, or you think I missed a step, or didn't explain why we were doing something, please use the Q&A to inquire. As usual, you can look at the title of the notebook to determine what notebook we are currently looking at. Okay, so let's start by downloading our S&P 500 CSV. Next, let's import our usual libraries, pandas, numpy, matplotlib, plotacf, and plotpacf. Next, let's read in our CSV using pd.readcsv. Next, let's filter out all of Google's close prices. Next, let's write a helper function to calculate the log return of a series. So as input, we're going to take in a series called price. Next, we'll calculate the log price by taking the log of the price. Next, we call the diff function to take the first difference of the log price, which is the log return. Okay, so you might be wondering, why are we taking the log return? Why is this what we care about? Well, you may have forgotten by this point, but remember that when we apply the ARMA model of ARIMA, we want that signal to be stationary. In our stationarity lectures, we already established that taking the first difference of the log prices, i.e. the log returns, yields a stationary signal. Of course, you could do the test again in this script, but I'll leave that to you as an exercise. Next, we'll apply our function to calculate the log return on Google stock prices. Next, let's do a df.head to make sure our data frame contains the right thing. Okay, and it does. Next, let's plot the PACF of Google's log returns. Remember, this is for choosing the order P of the autoregressive model. Okay, so what do we see? Well, pretty much that there is no autocorrelation for any order P greater than 0. We see a couple values just slightly outside the confidence bounds, but these are likely due to chance. As you recall, even IID noise can lead to the same plot. Okay, so according to the PACF, we would choose P equals 0. Next, let's check out the autocorrelation, or the ACF. So this looks pretty much the same as the PACF. In other words, we would choose Q equals 0 also. So what can we conclude? If we use the PACF and ACF method to choose our ARIMA orders, we would choose ARIMA 010. What is ARIMA 010? Well, that is a random walk. Okay, so maybe that was just a fluke. Let's now try Apple's stock price instead. Alright, so this is all the same code as before. Let's filter out Apple's close price. Next, let's calculate Apple's log returns. Next, let's look at the PACF for Apple. Okay, so what do we see? Again, pretty much the same picture. there are really no significant PACF values, and therefore, we would choose P equals 0. Okay, so what about the ACF? Again, this looks pretty much exactly like the PACF, so we choose Q equals 0. So what do we conclude? If we go by the ACF and PACF method, we would conclude that Apple's stock price follows a random walk. Okay, let's try again. This time we'll do IBM. Alright, so here's the PACF. And again, we see the same pattern. We choose P equals 0. How about the ACF? Again, the same pattern. We choose Q equals 0. Notice how closely the PACF and the ACF track each other for all the plots we've looked at. Consider why this might be the case. It should make sense when you think about the formula for calculating the PACF. In any case, for IBM, it's pretty much the same situation. We choose ARIMA 010, or in other words, we choose random walk. Okay, so let's try this one more time, this time for Starbucks. Alright, so here's the PACF. Now notice for Starbucks, there's kind of a non-zero value at lag 3, but I would consider this pretty unlikely to be actually significant. I would be comfortable saying that P is equal to 0. How about for the ACF? Again, it looks just like the PACF, so let's say Q is equal to 0. Alright, so for every stock we looked at in this lecture, if we use the ACF-PACF method of choosing ARIMA orders, we would choose ARIMA 010 every time. In other words, the random walk is actually a pretty nice fitting, parsimonious model for stock prices.